Hello everyone, welcome to Digital Image Processing class. In this video, we will introduce MATLAB Filter Convolution function, CONV2, and how to implement your own filter convolution function in MATLAB. MATLAB has a built-in function named CONV2 to perform filter convolution. This function computes the two-dimensional convolution matrix I, which is the image, and H, that is the filter. Please recall that the filter convolution process includes align the center of the filter to a pixel in the image as shown in the green area to extract the covered area. Then, we multiply the extracted area with the filter. Then we take the sum of the multiplication results and divide it by the sum of the filter. This will enable us to produce a single value and store it in the output image. The syntax of CONV2 is shown on the screen. Here, we provide an example of how to use CONV2 function. Assume we have an image I of size 1 by 10 and a filter H of size 1 by 3. We convolute the filter H on I using CONV2 function, and the results are stored in a variable fi. As you can see, when we apply the center of filter H on the first element, 1 in I, there is no value on the left. Based on the zero padding, we need to add a 0. And then we multiply by the cover area with the filter H. And then we add the sum of the result, multiplication result, and then divide it by the sum of H. So this will result in the 1. Actually, the calculation is the average. So basically, the average of 0, 1, 2 is the 1. Similarly, when we move the filter to the second element, 2, so we are going to calculate the average of 1, 2, 3, where the result of that is 2. Then we can move our filter to the third element. So we are going to calculate the average of 2, 3, 4. And the result of the average is 3. We can repeat this process until we reach the ninth element. After we calculate the average of 8, 9, 10, we are going to move the center of the filter to the element 10. This will result in an uncovered element. So therefore, we need to pad 0 on the right. So once we calculate the average of 9, 10, and 0, we get 6.3333. This method is called moving average technique, which is commonly used by finance people to calculate the average stock value. Here we provide another example by applying a two-dimensional filter H on a two-dimensional image I. As you can see, when H is composed of all ones, we calculate the average of an area, of the covered area. So for example, the green area means when we apply the H, the center of the H on the element 5 in I. So the average of the green rectangle in I is 11.1111. Here, we provide an example of how to implement filter convolution without geometry boundary padding. In this example, we assume that the size of the filter is 3 by 3, and we do not implement geometry boundary padding. And thus, the 3 by 3 filter is only applied on the full coverage area. In the example code, we create a MATLAB function named filter convolution. The input to the function include the first parameter is a grade level image, IMG, and the second parameter is a filter H. The output is the filtered image, IME. The first step is that we need to obtain the size of the input image, IMG, by using the size function. We store the number of rows and the number of columns in rows and columns, respectively. The second step is that we create an empty output image, IME, where its size is identical to the input image, IMG. As the sample code does not offer geometry boundary padding feature, therefore, we can only convolute the filter H within the full coverage region. In this example, we assume that the filter H is a 3 by 3 filter, and thus the upper left and bottom right coordinates of the full coverage region are 2, 2, and rows minus 1, rows, columns minus 1. According to the full coverage region, we use a nested for loop to iteratively move the center of the filter, which is RIDX, CIDX, on the image to extract the covered area T from the input image, IMG. To convolute the filter on the subimage T, we perform element multiplication between H and T. Then, we take the sum of the multiplication results and then divide it by the sum of the filter H to produce a single value to store in the output image, IME, at location RIDX, CIDX. We repeat this process for every pixels within the full coverage region. Thank you for watching.